Hi everyone. In this video, we will go through concepts on increasing and decreasing functions and problems related to them. Increasing and decreasing functions. Let's take this particular graph. We have this particular curve and we have say 2 points x1 and x2. x1 is lesser than x2 in this case, right? As the values of x increases, the value of y should also increase, right? What is y? Y is nothing but f of x. We are calling y is nothing but f of x. F of x is equal to y is equal to some function which has x in it, right? Say x plus 2. So you can either call it as y or you call it as function of x. Both mean the same. Now, in this particular equation or in this particular function, as the value of x increases, if the value of y also keeps increasing, then we call this particular function as an increasing function. As the value of x increases, say first I'll put x is equal to 2, then I'll put x is equal to 3, then I'll put x is equal to 4. As the value of x increases, the value of y also will increase. So y would become in this case 2 plus 2, which is 4. Then next value 3 plus 2, which is 5, 4 plus 2, which is 6. So if you notice here, as the value of x is increasing, the value of y or f of x is increasing. This particular function is called increasing function. Just to give an example. Alternatively, we can also say dy by dx, that is derivative of this function. Derivative of this function, if it is greater than 0, that is it is positive, then we call it as increasing. How do you find the derivative? You have f of x is equal to x plus 2. Now I'll find the derivative. How do I denote f dash of x is the derivative. So what is the derivative of this? What is derivative of x? 1. What is derivative of 2? 0. So derivative of this function is 1. 1 is greater than 0. So you call this as an increasing function. So there are two methods. One is you put different values of x. As the values of x increases, the value of y should increase. Or you can also say derivative of this function should be greater than 0. Rather, it should be positive. Right? It is 1 here. It can be 2, 3, any positive value. Any positive value, we call it as increasing function. Now, similarly, what is a decreasing function? As the value of x increases, the value of y decreases. Notice here, right? This is how it will be. Here x, it's increasing from x1 to x2, but y, notice here, this is y, right? This entire thing is y. Y is decreasing compared to this, right? So this is called as a decreasing function. Now let's take this particular example. Let's say this function f of x or y, right? F of x or y is equal to 4 minus x. Now I'll try to find out the values of f of x when values of x are 2, 3, 4, right? Let me take when x is equal to 2, what is f of x? F of x is 4 minus, instead of x I'll put 2. It's going to be 2. Now I'll take when x is equal to 3. When x is equal to 3, f of x is equal to 4 minus 3, which is 1. When x is equal to 4, f of x is equal to 4 minus, instead of x I put value of x, which is 4, which is 0, right? Now you notice x values is going from 2, 3, 4. It's increasing. And y values is 2, 1, 0. This is decreasing, right? So this kind of function is called as decreasing function. Now alternatively, we can find derivative of this. We can find derivative of this. What is derivative of this function? Derivative of 4 is 0. Derivative of x is 1. 0 minus 1 is minus 1. So this is nothing but less than 0. So whenever you have derivative of the function as less than 0 or negative, less than 0 is negative values. We call it as decreasing function. Now there is another function where it will neither increase nor decrease, right? It will remain stationary. That is, whatever values are there for x, right? Whatever values you take for x, y will be stationary, y will be fixed. If you look at this, y is same, y is constant. So we call such functions as neither increasing nor decreasing. There is no increase nor decrease. The function is stationary, right? The values of y is same. Alternatively, we can say if I take the derivative of this function, right? If I take the derivative of this function, it's going to be 0. At some point of x, the derivative is going to be 0, right? And that point is called as critical value of the function. Let's take an example. Let's take this function. Let's find the derivative, right? I'll find the derivative. So it will be 8x minus 8. This is the derivative. Now I'll take the value of x. Let's take value of x as 1. So what will happen? What will be f dash of 1? What will be derivative when x is equal to 1? It will be 8 into 1 minus 8, which is 0. Now we see the derivative of the function is 0 when x is equal to 1. We call this as critical point. When x is equal to 1, derivative of the function is 0, and we call this as critical point. Now let's take another example. Say f of x is equal to 2. Simple function. If I take derivative of this function, what will it be? It will be 0. Derivative of a number is 0. What will I call this function as? Neither increasing nor decreasing. Now what is the difference between this and this? In this function, based on the values of x, the function can be either increasing or decreasing based on the values of x. And at some point, at some value of x, the derivative is going to be 0. In this function, irrespective of whatever is the value of x, the derivative of function is 0. So this becomes neither increasing nor decreasing. Now if I take some other value here, say I take x is equal to 2. When x is equal to 2, it's going to be 8 into 2 minus 8. It's going to be 8. Now let's take x is equal to 3. It will be 8 into 3 minus 8, which is 16. Now you notice here f dash of x is greater than 0. So this is increasing function. Increasing function when x is equal to 2, 3, 4 and so on. Now let's take few examples. Find whether the following functions are increasing or decreasing or neither. A function is given here. X values are given here. We need to figure out if this function is increasing or decreasing or neither. So what is the first step? Step 1 is find derivative of x. First step is find derivative of x. This is the first step. Step 1. So what is derivative of x here? For x to the 4 is 4 into x cube. 4x cube. This is 3 into x square plus 22 into 2x minus 24 into 1 plus 0. This is the derivative. 4x cube minus 24x square plus 44x minus 24. They have given two values of x here, 0 and minus 2. Let's first take x is equal to 0. At x is equal to 0, we'll have to find what is the value of the derivative when x is 0. So we'll substitute 0 here. Instead of x, we'll put 0. So it will be 4 into 0. Everything is going to become 0, right? And we'll be left with minus 24. We'll be left with minus 24. Minus 24 is less than 0, right? Since minus 24 is less than 0, we call this as decreasing function. We say the function is decreasing when x is equal to 0. Now we'll take the second one. At second point, at x is equal to minus 2. So we'll substitute x as 2 here now. So we'll get 4 into 2 cube, 24 into 2 square, it's minus 2. Then plus 44 into minus 2 and minus 24. So what do we get? We get minus 240 less than 0. Since minus 240 is less than 0, we call this as decreasing function at x is equal to minus 2. Decreasing function at x is equal to 0. Decreasing function at x is equal to minus 2. Now let's take another example. This is another function. We'll have to find whether it is increasing or decreasing at these points. X is equal to 1 and x is equal to minus 1. Now what is step 1? Step 1 is to find the derivative, right? Derivative you find. Then at x is equal to 1, you substitute at x is equal to 1. Substitute x is equal to 1 in this function, in this derivative function. You will get one value. Now it is minus 6 here. This is less than 0. Hence, function is decreasing at x is equal to 1. Now let's substitute x is equal to minus 1. At x is equal to minus 1, substitute in this derivative. Substitute always in the derivative. So you'll get 54, which is greater than 0. Since derivative of the function is greater than 0, we say function is increasing at x is equal to minus 1. Now this is another example. We have square function here. We'll have to find out whether it is increasing or decreasing at these particular points when x is equal to 1 and x is equal to 3. So here again you'll start with finding derivative of x, right? You'll find derivative of this one function. So here you'll have to apply product rule, right? You have to apply product rule. So let's solve this step by step. So first step is find the derivative. You'll have to apply product rule. Product rule, say this is first function, this is second function. Based on product rule, first function into derivative of second function plus second function into derivative of first function. Now this is again, you need to split this. X minus 2, the whole square is nothing but x minus 2 into x minus 2. So again you have to apply product rule within this. So now I have to take product rule here. So this will become first function, this will become second function. So first function into derivative of second function plus second function into derivative of first function. Here both are same because it's a square function, right? Now I'll take this x minus 2 the whole square. What is derivative of x? Is 1 and derivative of 1 is 0, right? Now let's solve this. So we'll get x minus 1 into x minus 2. What is derivative of x? 1. Derivative of 2 is 0. Similarly, you will copy here x minus 2. Derivative of x is 1, 2 is 0. Plus x minus 2 the whole square into 1. So let's simplify this. X minus 2 into 1 is x minus 2. X minus 2 into 1 is x minus 2 plus x minus 2 the whole square. So this is nothing but x minus 1, x plus x is 2, minus 2 is minus 4, 2x minus 4 plus x minus 2 the whole square. This is derivative. Now I can take 2 common here, right? So this will become x minus 1. I'll take 2 common, so I'll get x minus 2 plus x minus 2 the whole square. Now what do we have to do? We'll have to substitute now. We'll have to substitute at x is equal to 1 and 3, right? So we'll first take at x is equal to 1. We'll find what is the value of derivative. So we'll substitute x is equal to 1. 1 minus 1, 0. Since this is 0, everything is going to become 0 only, right? 1 minus 2 plus 1 minus 2 is minus 1 the whole square. This entire thing is going to become 0 because it's 1 minus 1. Minus 1 the whole square is plus 1. So you get 1. Now this is greater than 0. Since 1 is greater than 0, we call this as increasing function at, we say f of x is increasing function at x is equal to 1. Now we'll take at x is equal to, what is the second point? Second point is x is equal to 3. Here we'll get 3 minus 1 into 2, 3 minus 2 plus 3 minus 2 the whole square. So we'll get 2, 4, 4, get 4 plus 1, you get 5. 5 is greater than 0. Therefore we say f of x is increasing function at x is equal to 3. So basically at both these points, f of x is increasing at both these points. Now let's take another function. We have this particular function. Here again, as usual, you'll find the derivative. You'll get this particular value. Now, if you try to find the values of x, you'll get x minus 2 and x minus 2, right? You can do that. X square minus 4x plus 4. When I try to find the numbers will be 2 and 2. 2 into 2 is 4. 2 plus 2 is also 4, but I want minus 4 here. So what I'll do, I'll take both the numbers as minus 2, right? This is nothing but x minus 2 into x minus 2. That means it is x minus 2 the whole square. Whenever you see a square function, you can straight away say that it is an increasing function. Why? Because whatever values of x you put, whether you put positive value or negative value, the result is going to be positive. Minus 2 the whole square is also 4. Plus 2 the whole square is also 4. So whatever you have within the square will always give a positive value, right? Which means it's going to be greater than 0. And let's not forget this also. You need to always look at the number outside. Number is also positive here. It's plus 3. So you're multiplying a positive number with a positive number. So this function value is going to become positive. So therefore it is increasing. We always tell for all values of x. Because any value, you can take positive value, negative value, anything. It's ultimately going to become an increasing function because the value is going to be greater than 0. Right? Say I take, instead of x, I take say minus 3. Right? I'll take minus 3. Right? I'll take x minus 2, the whole square. So if I take x as minus 3, I will get minus 5. And minus 5 the whole square is 25. So it's greater than 0. Now I'll take x is equal to plus 3. Right? So it will be 3 minus 2 the whole square. This will be 1 square. 3 into 1 is 3. Greater than 0. Right? In both the cases, values will be greater than 0. You can take any value of x and cross verify. That's why we say this particular function is an increasing function for all values of x. This is very important. For all values of x. Now let's take this function where you'll have to figure out if it's increasing or decreasing or neither increasing nor decreasing. The value of x is given, right? Now we find the derivative. Since the value of x is given, you substitute the value of x in the derivative function. You're getting 0 as the answer. Remember one thing, whenever the derivative of the function is 0, we said that function is neither increasing nor decreasing. At x is equal to 1, it's neither increasing nor decreasing. We have to write this. Let's take this another example. Find the critical points of function here. So what is the condition for critical point? F dash of x should be 0. If f dash of x is 0, we'll get the critical point, right? This is the condition. So what we'll do, we'll first find the derivative, right? We get this derivative. You have to find the roots, right? You have to find the values of x. So you get x minus 2 and x minus 1, right? Now, if you have to get the critical point, you have to make this function equated to 0. You have to equate this function to 0. You have to say derivative of the function is equal to 0, which is 6 into x minus 2 into x minus 1 is 0. You equate it to 0. So you'll get the points as x is equal to 2 and x is equal to 1. Simple. So the critical points are 2 and 1. The values of x are 2 and 1. Critical point is always the value of x, right? Value of x when f dash of x is equal to 0. When derivative is 0. This is another example. Find the stationary points and the corresponding value of the function. Right? Again, find the derivative. You get this one. Right? From this, you always equate x minus 3 equal to 0, x plus 1 equal to 0. So you will get x is equal to 3, x is equal to minus 1. You get x is equal to 3, x is equal to minus 1. We'll have to always put the derivative as equal to 0. And another part of the problem is find the corresponding value of the function. You have to find the value of the function at these critical points. So I have to take x is equal to 3, substitute in this function and find the value, minus 22. Similarly, take x is equal to minus 1 and substitute in this particular function and get the value. You have to find the corresponding value of the function, right? So you put the critical points, substitute it in the function and get the values. This is another example. Find where the critical points exist. You have f of x as e to the power x plus 1 and you have to find at x is equal to 0, check if critical point exists. So derivative, derivative of this is derivative of e to the power x is e to the power x itself. Derivative of 1 is 0. Now you substitute the value of x as 0, right? So you'll get e to the power 0. E to the power 0, anything to the power 0 is 1. Anything to the power 0 is 1. So it's always greater than 0, right? Since it is greater than 0, critical point does not exist, right? For critical point to exist, derivative of the function should be equal to 0. Only if derivative of the function is 0, critical point exists. We say critical point exists. But here, derivative is 1, which is greater than 0. So there is no critical point. It is not equal to 0. Therefore, there is no critical point. With this, we have come to the end of this particular topic. We will cover a few more problems related to finding intervals in the next video. And if you have liked this video, do press a like and share it. Thank you.